When we use the intermediate value theorem, I always want to make sure that when we're using some sort of theorem or definition to verify a claim, that we have a roadmap for what needs to be said. So in order to use the IVT, which stands for the intermediate value theorem, in order to use it to claim the existence of a value, which we're using C here, but in order to say that, hey, there's a value of C on the interval A to B, the closed interval, such that f of C is equal to some sort of value D, the following two things have to be stated. So in order to use this, two things have to be said. First and foremost, and really the thing that's very critically important to this IVT, is the fact that f of x, our function, must be continuous on the closed interval a to b. If you remember when we talked about continuity over an interval, we said there were a lot of functions that were continuous across their entire domains. So for example, a polynomial function is continuous for all real numbers, which means it's going to be continuous on some sort of closed interval where we're going to be zeroing in on. The other thing that we have to do is we said that D has to be some sort of value in between f of A and f of B, and so we need to verify that as our second bullet point. We need to say either that f of A is less than or equal to D, which is less than or equal to f of B. And this is kind of what we saw in the graphical representation that I drew in the previous video. It can also be said, really all that has to happen is D has to be sandwiched in between f of A and f of B, and that could happen if f of A was greater than or equal to this value D, which is greater than or equal to f of B. If you can say that it's continuous and that that value D is in between f of A and f of B, then you can say that there exists at least one value, C, on the closed interval A to B, such that f of C is equal to that value D. And again, it guarantees at least one value. It doesn't guarantee only one value. It also doesn't guarantee multiple values. It just guarantees that in order to go from f of A to f of B, you have to go through every value, which if D is in between f of A and f of B, then that means that somewhere you had a function value that puts you equal to D, and that's what this is saying right here. So it guarantees at least one value, but that's all you can really say about it.